Hi, this is the Gap Assessment Calculator, Year 11, Paper 3 from September 2020. So question 1 was a substitution of values into a term to find out the answer. You were given the value of x as 0.7. You then had to replace x into the equation in two places, one in your top bracket and then one in your denominator. So we do the 0.7 plus 1 squared. So we can type all this into our calculator in one go. We then divide that by 2 times 0.7. It asks us to write down all the numbers on the calculator display. So we should have been showing it as 2.06428571 with between the 4 and the 1 recurring. So you could have either showed the recurrence or you could have continued after if your calculator showed that. Question number 2. You were given two rectangles. I'll just zoom out a bit so it can be a little bit more visible. We were given two rectangles and we're told that the areas were equal to both. Okay, so we've got the equation for A. Well, the area for A is going to be the width times by the length. So it's 4x multiplied by 2.5. 4x multiplied by 2.5 here gives us 10x. We've also got the area for B, which is 7 multiplied by 2x times 2x minus 3. It's 2x times, it's 7 times all of 2x minus 3. So we end up with 14x minus 21. I can then put these two parts here equal to one another. And that's what I've done here. I've got 10x equals to 14x minus 21. And then from that, I can subtract 10x from both sides. And that leaves me with just 4x minus 21 equal to 0. If I take the 21 over to the other side by adding 21 to both sides, I get 4x equals 21. Therefore, I can find the value of x to be 5.25. The question was asking us to work out the perimeter of rectangle B. Well, that is all the way around. That'd be the same as 2x minus 3 plus 7 times by 2, because the 2x minus 3 is here and it's, the 7 is also there as well. So if I substitute in my value of x, I've got two lots of 5.25, the 2x, 2 times the x value, subtract the 3, add the 7 for this side, and then times it by 2, put it all through, and I get an answer coming through as 29. Question 3, we were asked to simplify some algebra to start with. So I've just written it because it was printed on the bottom of page 1. We had a 3y plus 2x minus 4 plus 5x plus 7. So again, I've grouped together the parts that are similar. I've got my 2x and my 5x together. They come together to make a 7x. I've got minus 4 plus 7 coming together to get me 3. And the 3y, there was nothing else with it, so I've just got 3y. They can be written in any order as long as the number in the front of them is the right one. For part B, I'm being asked to factorise. It's worth 2 marks, so I'm going to be factorising two different things. I can factorise a number. 2 goes into both 2 and 4, and x goes into both x squared and x. So I can take x out. Okay, so put 2x on the outside because that divides into both terms. And then I need to think about what I multiply my 2x by to get back to my original term. 2x multiplied by x gets me 2x squared. 2x multiplied by minus 2 gets me minus 4x. Next was to expand and simplify. So we have to be careful here that it was a minus 3 times by an x and a minus 3 times by a 2. Minus 3 times by 2 gets me negative 6. So I've got 11 subtract 6 giving me 5. And there is nothing else to simplify that minus 3x with. So it just becomes minus 3x. Part D of that algebra set of questions was to expand and simplify. So remember, we have to multiply everything in the first bracket by everything in the second bracket. I've chosen to do this using arrows. So my arrows from the first x go to both the 3x and the 7. So x times 3x gets me 3x squared. X times 7 gets me 7x. I repeat the process for everything else in that first bracket, which is a negative 6. Negative 6 times 3x gets me minus 18x. Negative 6 times by positive 7 gets me a minus 42. I can then group together the 7x and the minus 18x to end up with minus 11x and with the two other terms. Question 4, you were given some values in a table. You are asked to complete the missing values in that table. So again, this is a case of substitution, just like question 1. I'm needing to replace x as minus 1 into my equation. Well, minus 1 squared is 1. Minus 5 lots of negative 1. Well, minus 5 multiplied by negative 1 is plus 5. So I'm now at 1 plus 5 plus 3. That gives me an answer of 9. When I substitute the value of 2 into the equation, I've got 2 squared giving me 4, and then subtracting 5 lots of 2, which is 10. So I'm at 4 minus 10 plus 3 leaves me with an answer of minus 3. I'll do it one more time. I need to sub in 4 this time. So 4 squared gets me 16. Minus 5 times 4 gets me minus 20. So it's 16 minus 20 plus 3 gives me an answer of minus 1. I need to zoom out that a little bit further for the next section, because what we're asked to do for this one was to then plot these coordinates. Okay, so I'm going to be using, with me just while I fold the page so it can be seen. I'm going to be using the coordinates that we calculated down here and plot them onto my graph here. Okay, so I'm given every x number between minus 1 and 5, so it's always between the minus 1 and the 5, all those. And then I'm given the values. I needed to find the 9 myself, so I've plotted my 9. We're given the 3, we're given the minus 1. I had to calculate the 3 myself. We're given negative 3, sorry. I was given that negative 3. I had to calculate that minus 1, and we're given this 3. Okay, because it's a quadratic, it should be a nice smooth line going through it. Don't give it a flat bottom. It needs to be a nice curvy bottom on the bottom and then rising back up. For part C, you can see, you may be able to see I've faintly circled where it crosses the x-axis. That is because this equation is equal to 0 when it crosses my x-axis. So then I'm just trying to read where these two numbers are. Wherever yours is, as long as it's in that right shape, it will be allowed. So my answers, I got mine crossing through at 0.7 here and 4.3 there. So that's allowed for that one. For question 5, I'll just go back in a little bit closer so we can see what we're looking at. For question 5, we're given some of the information and we're given fact about the other piece of the information. So I started off by writing A, B, C, D for Abby, Ben, Chloe, and Dinesh. So I was told Abby and Ben's amount was 2 to 7. I was then told that Chloe and Dinesh each got 1.5 the amount of Abby's. Well, C and D, that means I'm getting 1.5 lots of Abby's, which is 2. So 1.5 times 2 gets me 3. So both Chloe and Dinesh got 3 parts each. Altogether, the 2, the 7, the 3, and the 3, 2, 7, 3, and 3 gets me 15 parts in total for that ratio. That £360 is then shared into these 15 parts. Okay, so 360 divided by 15 gives me £24 per part of that ratio. We were asked in the question to calculate the amount of money that Ben gets. Well, Ben is getting 7 parts, so it's going to be 7 multiplied by the £24 per part, giving us a final answer of 168. Next up, you had a 5-mark question on trying to find an angle and also explain your reasoning. So to start off with, what I looked at, I realised that I got a straight line here. FCB is a straight line, and I'm given 135 of it, so I can calculate the missing angle by doing 180 minus 135. That gives me an angle of 45 for the inside of my triangle here. I've also at the same time, close to my diagram, explained what rule I've gone for. So I said that that is due to angles on a straight line equaling 180 degrees. Once I've got that 45, I can then use that with the fact that I know that angles in a triangle add up to 180. So there's my second reasoning given. And I've got the 180. When I take away the 70 and I take away the 45 that I found, I can calculate this angle here to be 65. Again, I've got angles on a straight line. ABE is a straight line. Well, if I now know that this angle up ABC is 65, I can say that CBE must be whatever's left over. So 180 minus 65 gives me 115. That's again for the same reason that it's angles on a straight line. So I've used that rule twice. So with 5 marks, I had to do 3 parts of mathematics and 2 reasonings. Or reasonings being the angles on a straight line and angles in a triangle. For question 7, we were looking at a regular shape. The fact that it told us it was a regular shape allows us to calculate various facts. I've gone about this in 2 different ways to get my answer. The first method that I've gone for is to show that exterior angles, if I was to do 360 divided by the number of sides, that will always give me my exterior angle of 72. Okay, so if I've got an exterior angle on a regular shape is 360 divided by the number of sides. In this case, that 72 must also be, if I split that x straight across there, I've got a 72 at the top and a 72 at the bottom. They add together to give 144. The other way to consider it, now there's more than one way to get interior angles of polygons, but I chose to do the 180 minus 72 give me 108. Well, if this part here is 108, my other angle in here is 108. Well, all of those add together to be 360. So I've done a 360 minus the 108 minus the 108 equaling 144. There is a common misconception that some people think that the interior angle of a pentagon is 72 and the exterior 108. Well, what you can also do is just check to see if it makes sense. You know the size of a right angle. When it goes across and it goes up, that would be 90. So that is clearly bigger than 90. So I need to work out, therefore, that it must have been the 108 with the 72 on the outside. For question 8, we have some standard form. We're asked to write 7.8 times 10 to the negative 4 as an ordinary number. That means it's going to be a very small number. And that if I'm looking at where my decimal point now is compared to where it was before, it has moved 4 times. Okay, so I've divided by 10 4 times in order to get my answer of 0.00078. I was then given 95,600,000 and asked to write that as standard form. So my decimal point originally was after that last 0. It is now between the 9 and the 5. So in order to get from the 0 to between the 9 and the 5, I need to I need to times by 10 7 times. So I can see that I've got 3s there, another 3 there, and then one more move to get it between those. Question 9 was expanding and simplifying again. So this was just testing that you can expand with numbers at the front of your x's. This method, this time I've gone for using the grid. So I've got the 5x and the 2x minus the 3 down the sides. It's a case of multiplying 5x by 2x getting me 10x squared. 5x by minus 3 gets me minus 15x. Then I've got 2 times 2x getting me 4x and 2 times minus 3 getting me negative 6. I can then group together the 4x and the negative 15x to give me minus 11x. Okay. You were then asked to factorize. So that's putting back into brackets. The only way to get an x squared is an x multiplied by an x. And then I'm looking for product and sum. I'm needing numbers that multiply to be 3 and add to be 4. Those two numbers will be 3 and 1, so they go in the brackets. You can always check on these by expanding your brackets back and making sure you get the same answer as you started with. Question 10 was some trig. So I started by labeling my sides. I can label my longest side as my hypotenuse. The angle opposite, the length opposite is given the label opposite. And then I'm needing to know which of my ratios has opposite and hypotenuse in it. It's the one with sine. So it is sine of your angle is equal to opposite divided by hypotenuse. So I said sine of 30 is equal to opposite divided by 18. And to get opposite by itself, I need to multiply both sides by 18. So I got 18 times sine 30 gives me an answer of 9. And I needed my centimeters because there was no units on my answer line. Question 11, I've gone in quite a lot of detail here because it's a common question that people make errors on. They seem to find the upper and lower bound of an answer rather than working out the upper and lower bound in the question and then getting an answer from it. So my demonstration, I've taken the number P and I've drawn a number line for P. We've got the number that we were originally given, 5.37, and I've gone up and down in both directions, counting in decimal places that we were rounding to. So 5.37, 5.38 above it, and 5.36 below it. That means that my upper and lower bounds are the numbers that between these two, it rounds to. Anything bigger or equal to 5.365 will round up. So all those will go up to 5.37. Anything less than 5.375 will go down. Okay. So those are my upper and lower bounds. The 5.375 itself will go up to 5.38, but we just want to know that's how we label our upper and lower bounds. Similar fashion for S. This time it's to 1 decimal place, so I've gone 1 decimal place below and above. 2.9 goes down to 2.8 or up to 3.0. I then go between these two to just work out what numbers are going to go up to and down from. Okay, so any number between those will always round to 2.9. Then I need to think back to the question. I'm being asked to find the upper bound of m, and the way we calculate m is 1 divided by a number. Well, in order to make m as big as possible, I want to divide 1 by a number as small as possible. To find the smallest possible number, I need to take both of my lower bounds. Okay, so I'll take both my lower bounds. It's PS as your denominator, so that's a multiplication of your two lower bounds, and then it's 1 divided by such item. 0.0654011 was the first few numbers on my calculator. I write all that down because it clearly says you must show you're working. The reason for that is that had you made an error in understanding of the skill, you may end up with a very similar answer to what you're expected to get through correct working, which is why some of you may have got the same answer, but you will not be awarded the marks because you've not used the correct method. Maths is about understanding of method as well as getting right answers and wrong answers. Okay. The reason I've rounded my answer to 0.65 is because the number with the most decimal places had 2 decimal places in it, so I've also gone to 2 decimal places. Question 12, you are asked to find the solutions to an equation of 3x squared minus x minus 1. When it tells you to find it to 2 decimal places, it's giving you a massive clue that you're going to use a quadratic formula. Okay, and the quadratic formula you should start to be memorizing by now is minus b plus or minus the square root of b squared minus 4ac, where all of that is divided by 2a. If we go back to the question itself, in here, it's a number in front of your x squared is your a term. The number in front of your x term is your b value, and the number by itself is your c. So here we had a as 3, b is a minus 1 because there's no number in front of x, therefore it's a 1, and c is negative 1 as well. I then replace all those numbers into my equation, and it's always worth writing that down so your examiner can see that you substituted your numbers incorrectly. I then simplify that. Minus 1 squared, subtract brackets, and remember I'm wanting to multiply the 4 by the a by the c in one go. That's 4 times 3 times negative 1. So I'm going to get 1 subtract negative 12, which gives me 13, because subtracting a negative we will add together. So it's 1 plus or minus the square root of 13, all divided by 2 lots of 3, which is 6. Okay. When I do the first one, the 1 plus square root of 13 divided by 6, I get 0.77. And when I do 1 minus the square root of 13 divided by 6, I get an answer of minus 0.43. So that's why you give your solutions plural to 2 decimal places. I've got both my answers there to 2 decimal places. Question 13. Part A was asking us to find the equation of a straight line, which is parallel to y equals 5x plus 6. Well, parallel lines have the same gradients, so it was y equals 5x plus or minus absolutely anything on the end, as long as it was only a number, no extra letters. Okay, I just went for y equals 5x, so I went for the one that passes straight through the origin. For part B, this was a lot tougher. You were asked to find the equation of a line perpendicular to your first point, and then going through a particular point. I've gone about this in 2 different ways, depending on what your preference is and how you like to learn. Both of these are suitable at GCSE. So for a start, perpendicular gradients are negative reciprocals of one another. So that allows me to say that the gradient of the first is 5. So to get the gradient of the second, it's minus 1 divided by 5, or minus a fifth. Okay. Then on this side, am I working out? I've gone into y equals mx plus c, which is a general formula that you'll be aware of. I can then replace x and y with the coordinates that are given in terms of x and y. So y is worth 5, hence my 5 here. X is worth negative 2, hence my negative 2 here. So I'm saying that 5 is equal to minus a fifth lots of negative 2 plus c. Now it's a c we're after, so we can write an equation of a line. So I then have, if I was to simplify this, minus a fifth lots of negative 2 is 2 over 5, but that at the moment it's on the right-hand side of my equation. When I take it to my left-hand side of my equation, it becomes a subtraction again. So 5 subtract 2 over 5 will leave me just with C by itself. Therefore, C is 4 3/5. You could have written that as 23 over 5. You could, I may as well put, so you can see that that could also be 23 over 5. And once I've got that, I'm going back into my general formula, which is y equals minus a fifth x. Remember, it's minus a fifth because we know our gradients are perpendicular, plus what we've now found to be C as 4 3/5. The other way to do it, and those that are thinking about doing A level, is probably better to get used to this equation earlier rather than later. The equation is y minus y1 is equal to m brackets x minus x1. And the way that this one is used, we still need m because that's a gradient. It's just a case of x1 and y1 become the values that you substitute in, and it immediately leaves you in terms of x and y. So you don't need to worry about the x and the y that don't have any subscript notation on them. Just looking through what we do here. So we have, when we're substituting 5, I get y minus 5. M we know is minus a fifth, and it's x minus a negative 2. So when you subtract a negative, I tried to write it there and forgot. That's there. No, sorry. My bad again. No wonder I rubbed it out and made a mistake down here. When you subtract a negative, you end up with a positive. But then when we... no, I know what I've done. Sorry about that. I'll rewind. So back to this line. That is substituting everything in. We've got y minus 5 from here. Minus a fifth is our gradient. And then x subtract negative 2, we have x minus the... and then we're putting in the minus 2 here. My next line of working out, I've multiplied everything by 5. Okay, so 5 onto the left-hand side, 5 lots of y and 5 lots of 5. So I get 5y minus 25. And then I'm doing minus 1 multiplied by x, getting me minus x. I'm doing minus 1 multiplied by what is actually now a positive 2. So it becomes a negative 2 again. Okay. So when I take the 25 over to the other side, I end up with 23. So I've got 5y equals negative x plus 23. You'll realize both of these look completely different to one another, but they are the same equation, just written in a different format. And that is the end of paper 3. Thank you very much.